Thanks for coming. As there is no formal manager of the sequence of talks, I will take the opportunity to introduce myself. I'm kind of opening a window on SDN effort inside the government, and in that the Department of Defense. And the reason is that open daylight is getting a mature technology very fast, being deployed, and usually the government is a little bit late in coming to the technologies. By the nature of things, there are so many things which are already on the ground and installed, and it is working, that you want to wait a little until things are mature before you want to integrate with your existing system. So I thought this is a good opportunity for me to come here and learn what is going on. And in the morning's keynote, it was very exciting to see that it is being used in a very big way, and big name players are there, and things are getting more and more capability-wise richer and richer. So before going further, let me tell you about myself. I work in Army Research Lab. Many of you may already know, but still let me repeat. The three services, Army, and Navy, and Air Force, they have the research labs. These are like corporate research labs, and they focus on problems which are of relevance to the services, Army or Navy or Air Force. And as you can imagine, the problems can span all over the knowledge world. It can go from pure mathematics to pure physics to applied physics to engineering to IT and so on. So basically most of the engineering and pure sciences and applied sciences, they are covered. Coming back to the Army Research Lab, it is a lab based in Maryland, and also it has its satellite campuses all over the country. And it is about 1,000 to 1,500 PhDs working on PhD and masters and engineers working on problems at the cutting edge. Most of the work done is like universities. It is published. We go to conferences, exchange ideas. A small portion is so-called classified, secret, which is not released. You can understand those are also part of our job. But majority, say 90 to 95% work is in the open. It is in the journals, and we really talk to industry researchers, academic researchers. We have arrangements with a lot of universities, and basically you can understand the lab as being a good research university without the researchers having any teaching responsibility. So we don't teach, but we do a lot of research work. So okay, so the outline is here. I feel that I will be kind of preaching to the converted, because everyone knows what SDN is, and maybe some of you know quite a lot more than I know. But when I prepared these slides, I wanted to put forward my understanding of what SDN is and where will it fit inside DOD. So the first thing is that I want to describe to you what the DOD networks currently have, their salient features. And then you can look at itself like where are the things which need to be improved with the use of SDN approach. So that is the second part. Then I will just put forth some slides on what the SDN paradigm I mean by. And then what is the long-term vision. And these are kind of descriptive slides. And I will describe a few current SDN initiatives which we have, a couple of them inside Army Research Lab, and some in other service labs, and then future vision. So in one word, if I want to describe the current DOD networks, the word is heterogeneity. It is extremely heterogeneous network in multidimensional sense. It is heterogeneous in technology modes, channel types, technology generations, and you can understand why. If you just go a little bit back in history, you know that the internet was basically invented by DARPA in the form of ARPANET. That is when it was a DARPA program, and people who don't know DARPA, it's a Defense Advanced Research Projects Agency. It is the future-facing research arm of the Department of Defense. And they, in the 80s, they had this program called ARPANET, and that is the progenitor of the current internet. That is where everything goes back to. So you can see that the DOD networks have basically every component ever invented, and it is sitting there in someone's office somewhere. And all of them have to work together. No one throws anything out. It is very expensive, and Congress does not give us money, year after money, to really do the refresh all the time, because refresh is also expensive, quite expensive. And so our networks are heterogeneous. We have components and the devices going back 10s and 15 years back, and of course living with the current. Some of our agencies are smart enough and resourceful enough to really also purchase the latest and the greatest as well. So all of this have to be there together and work nicely. Especially in, I have not noticed one thing, and that is we also, in contrast to the private sector, we also have to deal with SATCOMs and the space components. So satellite communication is there, and space component services don't deal with it. NASA is there, but in the wider world, that also should be considered as a part of the networks. Then again, the same heterogeneity continues in software and services. We have everything there: packet-oriented, circuit-oriented, voice, video, images, everything. Transactions can be very short, just like the. And here, I don't think we are that different from the current existing networks, the AT&T or the Verizon networks. They also have these this special kind of heterogeneities, like transaction sizes and transfer rates. And even services, if you have a telecom network these days, even though we have the everything is packetized and IP, but still some portion still is the old TDM circuit oriented there. And quality of service, again, we have, if you are at the commander level, say generals, they want almost zero error in the transmission of messages, otherwise it will be very dangerous. And if you are down in the dungeon, and we can live with some errors, and maybe sometimes a lot of errors, because depending on the network connection in the field, it can be so, say, patchy, so much little going on there that the error is almost unavoidable. And the network management systems, here I should also explain this question of the administrative domains which we have. Our administrative domains are more than AS. So AS is, of course, one island of connected devices and the nodes and links, which has one kind of technology or the one kind of, say, overarching operator who declares, so this is my domain. And then you have another domain, say Comcast, Verizon, AT&T, and they have to talk together. Here, our domains are at various levels. So not only we have this technology and IP-like domains, but we have these domains. So this is Army's domain. This is Navy's domain and Air Force. Even though we are all part of the bigger government, but if you dig down, lot of, let's say, rivalry, and We don't want really to share. Army does not want to expose everything to Navy and vice versa and so on. All kind of things are there. And it is historical, and sometimes it is, it makes sense also sometimes. Because you don't want, especially in the security, for the sake of security, that everyone should know everything. So on the top of this kind of domain structure, we also have the so-called security domain structure. We have unclassified, we have FOUO for official use only, controlled information, then secret, top secret, and then even above top secret, there are 3 or 4 other classifications which are there. So you can see that, so the operating word is heterogeneity. This brings so much, say, complication to this DOD network that now you have to think, how can SDN help us? So again, this I already talked about, and I should also touch that there is another thing. We also have this coalition. We also work with our partners in treaty obligations. So ANZUS treaties, Australia, New Zealand, and United States. Then Canada and UK, they are all English-speaking countries which are tightly tied in many kind of obligations, and most of the time in the international arena they work together, depending on the tasks and international missions. But so many times this is standing, especially this coalition is a continuing existence. So we always have US and UK talking together on various things of interest, for example, and the Canada and so on. And then sometimes we have to go beyond that, like NATO, and NATO has European Union. And despite Brexit and this and that, those relationships stand. They are not abrogated. So the problem is that when you look at all this heterogeneity and try to understand in a kind of very general manner, you can see that they are all can be described as having many kind of interfaces and gateways, and at the technology level, that is how we access all those different domains. And this currently has this one of the well-known problems which SDN wanted to solve. We don't have global view. Programmability, forget it. If something happens, we always have to send someone to fix things, which will take maybe, if you are lucky, maybe 1 day. If you are not, maybe 1 week. Who knows? And this is the cybersecurity issues. This morning, I was surprised, well, not surprised actually, that not even once the 3 keynote speakers, they talked about security. That word was not even mentioned, security. But security is of such a prime importance to us, given the nature of DOD. Security at the cyber level, security at the physical level, everywhere. And cyber security is so important that, as you know, recently Cyber Command has been stood up. And we have, it is gaining traction. And how many people know about the DISA? Okay. So DISA is a Defense Information Systems Agency. And it is basically, you can say that it is the Google, Amazon, and AT&T and Comcast, all of them jumbled together in one agency for the government, for the DOD, Department of Defense. It runs one of the largest networks in the world. It is a global network, global in the truly geographical sense, all the continents and everywhere, because that follows from the fact that US is the sole superpower. So, and that is where our critics and adversaries, they really criticize us, like, you are really controlling the world. But that is the job it has been given. In some sense, US is called upon to solve problems all over the world, so it has to have a network presence all over the world. So that is the network DISA manages and operates. And so cybersecurity is of paramount importance because most of our assets are in the part of the world where we have, I should not say enemies, but adversaries. Because there is a distinction. Enemies really want to harm you. Adversaries sometimes don't want to harm directly, but they are always looking at how to take advantage of you. So we have all those players outside, state adversaries and the non-state actors, and you know what I mean, those players. So cybersecurity is a very important issue for us, and how do we operate, how do we implement security from the bottom up, taking care of all this heterogeneity? That is a very, very challenging problem. And SDN gives a paradigm where it may be possible. So we are kind of quite interested in that. So this is the current state of DOD stands for Department of Defense Information Network. There is a whole lot of acronyms inside DOD, which is a little bit different from the outside world. So even the DOD, I was told that it has been changed to DODIC, and C stands for center or something. I'm not very sure. But this is the current word. People who have earlier memory, it used to be called GIG, Global Information Grid, earlier. The same similar entity. Now it is called DODIN and DODIC. So here we have, here is a cartoon picture of the current state of Department of Defense network. We have, like every other big network, we have a core, an edge, and the intermediate, say, which had middlewares and all the other things. And this is based on the interfaces and gateways, as I mentioned earlier. Now I come to the next part of the presentation, which is my take on SDN, and it is very simplistic. For the people here, you know more, and at every level there are more complications. So what I want to say is that traditional network model is on the left-hand side, and the biggest problem there is it is opaque and not programmable, not flexible. So if you compare that traditional network model, then and look at the, say, computers. Computers in the early days were also like that, hardware bound and everything. Then computers developed and became programmable and flexible. Similar kind of revolution is going on networking. Networking, after the programmability came through SDN, we are talking about this whole ecosystem of open daylight, where we have different components where you can program and you can make network do what you want to do sometimes in real time. So this is what was lacking in traditional model, and if you look at the SDN part, it is a cartoon of the SDN network, and the idea is like here is the controller, centralized, which gives us a lot of good capabilities. And here is a Achilles heel. Because it is centralized, all our adversaries are looking at ways to compromise and attack and take control of it. So how to make network controller, SDN controller, cyber secure, that is one of the big challenges. At least in our mind, it seems like that problem, it has been solved, because I know that right from the beginning, the open flow and the controller communication is encrypted by TLS, and all those things have been done. But still, there are the new surfaces of attack which have arisen, and how to make network controller harden against them, that is one of the challenges. So again, the same idea which I want to present, that SDN I understand as basically 3 layers, and infrastructure, control, and applications. And I know that there is a lot more going on in, say, when you look at this interface, how does the SDN controller talk to these applications? Where a lot of these RESTconf and say MDSAL and lot of new acronyms which I have just learned together, they are operative. And when you go to the southbound, then you have the network devices, And for the time being, open flow is sufficient. But I will also say that open flow needs to be changing, and maybe people are already working on it in one sense, that if you look at open flow different versions, say version 1.1 to 1.3, the protocol fields which is covering is increasing. In every new release, it tries to take care of many more new protocols. So the danger is like as the new protocols are being developed, very soon the open flow will have to decide. It may have to just from performance point of view, it may not be able to take care of all the protocols. So then what will happen? So open flow has to change, and the idea of protocol oblivious forwarding or protocol independent forwarding is a new one, which many research institutions are working on, where whichever new protocol comes, open flow headers can cope with that. That is the idea. And that may have to be also thought of as being part of Open Daylight in the future. But open flow people are looking at it in the research, I know. So long-term vision of DOD is like there are different domains and they have different domain controllers. Now the other question which occurs is how do these domain controllers talk to each other? That is the east-west communication of controllers. And there the problem is that we don't have a standard yet. It is being worked on, but east-west communication has not been standardized. In contrast to, say, North controller and the devices, which is open flow. Open flow is standardized. So east-west is one of the big worries, and there another problem which people may guess here, and it is the problem of when there are more than one controllers controlling more than one domains, what is the best topology? Is it hierarchical? Okay, here there are five domain controllers. Maybe 3 of them are managed by one super SDN controller, 2 another super SDN controller, and over these 2 there is a super SDN controller. There is a hierarchy. Or maybe all of those controllers, they can be at the same level, and there may be some way, some protocol which can manage what each has to do. That is the peer-to-peer control. So that is one of the questions which need to be solved, and I don't know, Open Daylight, I have to learn more about it, like how it does it, or whether it does not do it. I don't know. Maybe someone can tell me. So this is again the vision kind of thing, which may change in light of new developments. But this is what I currently think, so we have SDN capable core, and as again one more thing I should point out, and it was already talked about in the keynotes today. Transport layer SDN. So until and unless the SDN controller is also able to look and understand and program the analog layer, because optical, signals are analog signals. They are not, ultimately you have these laser pulses which are carrying the data in the optical network. And these are ROADMs which are managing that. They are kind of routers for the optical signals. So how does SDN reach goes all the way there in a seamless way, apart from layer 2 and layer 3 controlling the optical layer. Already the work there was, I think it was AT&T presentation where there was like Telia and AT&T and one more. They are working on this thing. And so this kind of advance is necessary, and we need that. I have skipped here. There are 2 more layers where that has to be done. That is the satellite layer, and another one is so-called aerial layer. This is a layer very specific to Department of Defense network. Aerial layer is, you can think of a lot of planes which are kind of in the sky, and they themselves are the routers. So between ground to the air layer itself is extension of the ground network. So that is another complication. How do you manage to have control through SDN kind of paradigm from aerial to the ground layer? This does not show that, but I just want to add that to the complication. So basically what I am telling you is how bad our situation is. So this is an idea that telecommunications, many people may know that SDN idea is in other language, in other way, it was already implemented in the telecommunication network before the IP, before the SDN came around. So telecommunication networks, they had their element management systems and network management systems, which basically did similar things as SDN controller is supposed to do. But this was in the device, this was before the IP became dominant. So there you can see we have this so-called EMS and NMS. So EMS is a vendor-specific island of network elements. So we have all the Ericsson, say, element device elements in the network. They will have one element management system, and say Alcatel-Lucent has another island and another element management system. They will be managed by a network management system, which will go higher management, which is called business management layer, BML, in the, say, telecommunications jargon. So it is a similar idea as we have SDN controller for the one domain, and then hierarchically controlled by super SDN controllers. So this was already talked about and well understood in the telecommunication world. So that idea we will be taking and we can employ in this situation. So again, we have multiple domains. Each AS has its own controller, and they are either peers or hierarchical. That depends on the requirement and the topology and optimization metrics. What is the metric against which you want to optimize this topology? And there is one very good approach called broker-assisted peer controller management. Some research has been done on that in the University of California system, actually Davis campus, and we are looking very seriously at that. So brokers are software modules inside the SDN controllers, and you have some metrics which they control and optimize. But these all are at the same level. They are not controlled by other supercontrollers. So this tells you that, okay, all these domains can exchange data and do calculations based on what they want to optimize. And that metric may change, that algorithm may change, depending on what you need. So this is a very interesting, exciting approach, which we are looking at from the research point of view, and how to have multi-domain network, SDN-controlled network in light of this idea. So now I will talk about a few of the projects which we have, just to give you a flavor. Inside Army Research Lab, we have SDN test bed, which was stood up last year. And we are very focused, because we are a research organization, so we have a small research network. It is internal. It is not a big network, but still it serves about 1,500 to 2,000 researchers. And many times their needs are, okay, they want to do some calculation, they want to do some networking experiment, and they want to take control of those assets, say compute, network, and storage assets, do their work, and then release it. You know, the slicing concept. This is very well known in the SDN world. So we are trying to implement that, and we have come a long way, and hopefully soon we should be, internally we will prove this concept, that it will be useful. And then this is what we have. This does not give the most recent picture. It's slightly dated. but we have one of the first Genie node inside Department of Defense. Army Research Lab implemented that. And our Genie node is DGA, that is the DOD Genie Authority. So if other Genie nodes come up later, we will be the authority for them. We will be the controller for them. Only thing is like not that, it is, again, because earlier when I said that we are slightly behind the curve, in this case, we are maybe a little bit more behind the curve. We still don't have many implementation of Genie nodes or SDN kind of things in other branches of DOD. We are at this time consider ourselves the leaders, Army Research Lab. Navy is thinking of doing that, and Air Force is, they are also doing. But when that will happen, we will know. People know that Genie is an academic effort. In academia, this is kind of SDN kind of approach, nodes, which connects almost more than 40, 50 academic institutions in the country. And it is very effective in large scale, large science networks, say high energy physics. If you are doing research in the Large Hadron Collider in Geneva, collecting the particle data, particle physics data, or if you want to do genetic engineering and all the genome data you want to analyze and collect, that kind of very large scale, or astrophysical data also. So Genie is very well known in the academic world, but inside DOD we want to also implement this. We have these researchers, different kind of projects, and we want to be able to do slicing and all those things. So that is where we come from. There is another area which I will just touch on, won't go into that much detail. You may have heard of quantum networking, quantum cryptography, quantum communication. We are interested in that. And even though it is academic research area, we are also interested in that. And idea is like the SDN, can it be modified to control a network in which the physical layer devices are quantum devices? So that is the basic idea. Right now our devices, which are say user edge devices, they are classical devices. Here classical and quantum, I don't want to go to the physics layer of that, but quantum mechanics is very different because of nature of reality, which tries to describe atomic and the photonic level. And there, the quantum devices, you may have read a lot of it in New York Times and other articles, that quantum computers are going to be very important within the next 30, 40 years, because they have the capability of future spurt in capability where they can solve problems which just cannot be even touched by classical computers. So that is the vision, quantum computers. And when these quantum computers, many of them are connected, that will be quantum internet, quantum network. So this is something touching on that. And how SDN can help, how the OSI layers, all the 7 layers of OSI, how can that be modified to accept the quantum data and connect the quantum network? So that is the research about. So another similar, not quantum, but another SDN related project which is going on inside Navy. And it is the naval battleship networks. And if you look at on the right hand side picture, SAT, that is a satellite data which is coming. So you can think of the ships are here in the ocean, many of them, and the satellites are in the sky. So it is the ships, you can think of the southbound, and satellites have the controllers are there, and how they communicate. So that is the idea here called naval battleship network. It is SATCOM based. And currently, they are looking at how to use SDN for flow optimization.
Wrap up pretty soon because these guys are ready. They're
Okay.
supposed to start at 4:15.
Okay, so I'm done. Someone should have told me. I'm sorry. I will be done very soon. Yes, someone should have looked at the watch. Okay, so this is one of the Navy programs. And finally, there are another idea is OSD is Department of Defense boss, Office of Secretary of Defense, basically, OSD. They are looking at using SDX for DOD networks, where SDS is for everything, X stands for other things. And the final slide, and that is, idea is that we want to look at how heterogeneous networking architecture can be helped by SDN. I explained earlier, looking at the transport layer and looking at the security in particular, including the optical, wireless, SATCOM, all in one unified manner. And finally, this I did not touch on, but I will just say that cognitive networking is also very important. How the cognitive aspect, machine learning, enters this SDN paradigm, that's one of the big things for us. Thanks for listening, and if anyone has any question. Yes.
I didn't understand what you just mentioned, the Genie project. What you need to do with SDN and Genie project?
Oh no, Genie is a platform, academic platform on which SDN has been implemented. So it is just enabler. So Genie is in academic world. We took it. We want to experiment with that inside. That is all. Okay. Has it been standardized by ONF? Okay. That is what I meant. Yeah, there is another called SDNI also there. So I'm aware of that, but not standardized. Thanks. It's published. We go to conferences, exchange ideas. A small portion is so-called classified, secret, which is not released. You can understand those are also part of our job. But majority, say 90 to 95% work is in the open. It is in the journals, and we really talk to industry researchers, academic researchers. We have arrangements with a lot of universities, and basically you can understand the lab as being a good research university without the researchers having any teaching responsibility. So we don't teach, but we do a lot of research work. So okay, so the outline is here. I feel that I will be kind of preaching to the converted, because everyone knows what SDN is, and maybe some of you know quite a lot more than I know. But when I prepared these slides, I wanted to put forward my understanding of what SDN is and where will it fit inside DOD. So the first thing is that I want to describe to you what the DOD networks currently have, their salient. Going further, let me tell you about myself. I work in Army Research Lab. Many of you may already know, but still let me repeat. The three services, Army and Navy and Air Force, they have the research labs. These are like corporate research labs, and they focus on problems which are of relevance to the services, Army or Navy or Air Force. And as you can imagine, the problems can span all over the knowledge world. It can go from pure mathematics to pure physics to applied physics to engineering to IT and so on. So basically most of the engineering and pure sciences and applied sciences, they are covered. Coming back to the Army Research Lab, it is a lab based in Maryland, and also it has its satellite campuses all over the country. And it is about 1,000 to 1,500 PhDs working on PhD and masters and engineers working on problems at the cutting edge. Most of the work done is like universities. It is. Thanks for coming. As there is no formal manager of the sequence of talks, I will take the opportunity to introduce myself. I'm kind of opening a window on SDN effort inside the government, and in that the Department of Defense. And the reason is that open daylight is getting a mature technology very fast, being deployed, and usually the government is a little bit late in coming to the technologies. By the nature of things, there are so many things which are already on the ground and installed, and it is working, that you want to wait a little until things are mature before you want to integrate with your existing system. So I thought this is a good opportunity for me to come here and learn what is going on. And in the morning's keynote, it was very exciting to see that it is being used in a very big way, and big name players are there, and things are getting more and more capability-wise richer and richer. So before that is when it was a DARPA program, and people who don't know DARPA, it's a Defense Advanced Research Projects Agency. It is the future-facing research arm of Department of Defense. And they, in the 80s, they had this program called ARPANET, and that is the progenitor of the current internet. That is where everything goes back to. So you can see that the DOD networks have basically every component ever invented, and it is sitting there in someone's office somewhere. And all of them have to work together. No one throws anything out. It is very expensive, and Congress does not give us money, year after money, to really do the refresh all the time, because refresh is also expensive, quite expensive. And so our networks are heterogeneous. We have components and devices going back 10s and 15 years back, and of course living with the current. Some of our agencies are smart enough and resourceful enough to really also purchase the latest and the greatest as well. So all of these have to be there together and work nicely, especially in features. And then you can look at itself, like where are the things which need to be improved with the use of SDN approach. So that is the second part. Then I will just put forth some slides on what the SDN paradigm I mean by, and then what is the long-term vision. And these are kind of descriptive slides. And I will describe a few current SDN initiatives which we have, a couple of them inside Army Research Lab, and some in other service labs. And then future vision. So in one word, if I want to describe the current DOD networks, the word is heterogeneity. It is extremely heterogeneous network in multidimensional sense. It is heterogeneous in technology modes, channel types, technology generations, and you can understand why. If you just go a little bit back in history, you know that the internet was basically invented by DARPA in the form of ARPANET.